second problem of January Lead Code daily challenge. And this is problem number 2. And the problem is find the corresponding node of a binary tree in a clone of that tree. And this problem was asked at Facebook also. So without further delay, let us jump into the problem statement. Given two binary trees, original and cloned, and given reference to the node target in the original tree, the clone tree is a copy of the original tree. Return a reference to the same node of to the clone tree in the clone tree. So basically, I'll just walk you through an example. So this is the original tree and this is the clone tree. Both are absolutely same. They just have separate references in the memory. They are absolutely the same structure. Okay, and we don't need to validate that also. So these two starting nodes of the cloned and the original trees are given, and the target node is given. So in this case, the target node is the green one, the 3. So you have to basically iterate the original binary tree, the left one, as you can see in the diagram, and find out where this target node matches and return the corresponding node where it matches in the clone tree. So the reference of that tree would be checked. Okay, so this tree reference should be the return node should be the one in the clone tree on the right side. And similarly for all other examples, you can just go through all other examples here. Now the thing is, there is also follow-up to this problem which says that solve the problem if repeated values on the tree are allowed. So let's say there are repeated values. So if all the values are 7, okay, in that case, how do we solve the problem? So we'll keep that follow-up in mind and solve the problem in that manner. So the first thing that comes up to my mind from this problem is a simple depth first search, DFS approach. So what if we can iterate both of these trees together parallelly? So if we have a pointer here and if we have a pointer here, if we can check on this on the original tree, if that is equal to the target node, then just return the pointer in the clone tree, the right side. Otherwise, you can just keep on iterating using a simple DFS and doing that parallel in both the trees. So let us try implementing that thought of DFS. It's a very simple problem, and I'll just code it out using Python. I'm doing Python, but you can use any other language. The implementation is very simple. So, okay. First of all, if original is not there, if it is none, it's none is same as null in Java and C++ and things like that. Okay, so it's just a Python syntax. So we return none. If original is original dot value is same as the target dot value, then you return the cloned, right? Now see, this part I want you to understand. So I am checking the values. This is what was asked in the follow-up, that if the repetition is there, if a repetition is there, you have to make sure that you're not checking by values. You have to check by reference. It said that if a repetition is there, then the problem should work. So right now my problem might not work if a repetition is there, okay? Because I'm checking by values. So let's completely remove the concept of values and let's check directly by reference. Why are we even checking values? Because I'm basically iterating both the trees parallelly, right? I can just check by reference. I don't need to check by values. And finally, you have to just return, basically check the left side, self.get target copy of original dot left. So we have to check the left side, we have to check the right side. Very simple. Okay. Or this is for the left, and for the right we'll do get target copy original dot right. So you have understood this part, right? We are iterating both the trees in the same manner. This first line number 14 is basically when both the pointers going to the left side of each left node of each tree, and the line number 15 is for going to the right side of each tree. So both of the pointers are moving parallelly, they are moving together, and we have to return this one or this one here. So I'll just, okay, looks good. So that is the solution using DFS. So I'll try some running this, and let's see if this works. Okay, I'll try submitting this. Great. So our solution got accepted, and as you can see, our solution got accepted here. Now, what is the memory we are using here? So the time complexity is big of n, right? DFS, and we are iterating all the nodes in the tree. So what is the time complexity? Time complexity is big of n. But what is the space complexity? Space complexity in DFS, we are using the internal stack. So the space complexity is log of n, the height of the tree. So given this tree, okay, given this tree, what is the log of n? The height of this tree. So this total maximum height, 1, 2, 4, and 8. This is the height of the tree. There are like 3 edges in this maximum length from root to the longest farthest leaf. So that is the height of the tree, and that is log n. Okay, so we are using a space of log n. But what if we use a BFS? BFS uses a queue, and we'll try to solve that in that approach as well, because many of you are looking for different approaches to solve a problem. So I have thought of discussing the BFS approach also. So what we do in a BFS approach, so I'll keep the solution here, I'll not remove it. Okay, so that you can refer. So in a BFS approach, so this is the DFS approach. And in the BFS approach, what we do, in the BFS approach, we'll use a queue, and we'll initialize the queue data structure with the root of the both of the trees. So original and cloned will go here. I'm using a tuple like structure. You can use a pair in Java, or it can also be another array. So it does not need to be a tuple. It can be another array, simple array. Okay, so but I'll use a tuple here for simplicity. And while the queue is there, so it's very simple breadth first search BFS. While queue is there, if so I'll just pop from the queue. So if original and cloned, so is basically dequeuing, queue dot pop 0. So if original is same as target, then you return cloned. Otherwise, just simply append. So q dot append. So q dot append is similar as enqueuing. So we are adding to the queue. So original dot left and clone dot left and q dot append original dot right and clone dot right. So that should solve the problem. Let us see submitting this. Yes. So let us see. We ran the code, it's working. Let us try submitting the solution and see if it works. Okay, so we are getting an error because we have not checked for null. So we have to check for null. Um, if original is equals to none, then you return none, right? Okay, we are getting a wrong answer. So let us see what is the issue. If original is none, so we are returning none. Let us visualize this problem. So this is that example where we have a, okay, the visualizer is not there actually. Okay, okay. Let us try understanding the code that we have done. If original is none, then we are returning none. Instead of doing that, what if we can just simply check if ori.left, then you put it in the queue. If ori.right, then you put it in the queue. Okay, so let us try with this approach. Seems like it's passing. Now let us try submitting this. Yes, that's the right thing. So we should have checked before adding to left and right. So the left and right should be in the queue, right? Another approach to this is, instead of doing this, if we could do it something like this. So this is one code, right? You saw this code. What if we could just check if original is equals to none, we can just continue. We don't do anything, we just continue to the next one. So I think this one should also work. Let's try submitting this. Perfect. This one works as well. So that's it. That's it for the solution. There's a DFS solution on top and the BFS solution here. And I hope you guys understood the problem and the solution. And another approach to solving this is like this. We just remove this part and we add if original dot left. Then you do this, and if original dot right, then you do this. That is another approach of solving this problem. So make sure you do understand all the solutions, and you should be able to debug the problem. So the way we debugged it on the video, you should also be able to debug it during an interview. So that's it for today's video, and I hope you guys enjoying the videos. So do share, like, comment, and let me know how you guys are liking the videos. Should I add something? Should I explain in a different manner? What problems you want me to cover? I would love to cover. I would love to read your comments and interact with you guys. So that's it for today's video. Hope you guys enjoyed it and had a good time. Thank you so much. Have a great day.